Okay, so we're going to use row operations like we used last week, but we're going to use them to solve a system. Now, when we're solving a system, anything smaller than a 3 by 3 or 3 by 4, I should say, it's probably easiest to do substitution or elimination. 3 by 4 really could be quicker, solved with row operations. Anything bigger, you're going to have to do row operations. So we're going to get it into what's called row echelon form, REF. This is what it looks like. So we get 1s in the diagonal, 0s in the bottom right, bottom left I should say, and then the top right can be anything. So in the past you guys turned these back into 0s, now we can leave them. So it's a little bit quicker. First step is to create an augmented matrix, which I have here, and then we're just going to work through it turning 0s and 1s. So the top left needs to be a 1, already is. We're going to drop down, turn this into a 0. So I'm going to do negative row 1 plus row 2. So that's going to keep row 1 and row 3 the same. So it's no different. Row 2 is going to change. So 0, negative 3, 1, and 4. Now I'm going to turn this into a 1. You could also go back here and turn that into a 0. It doesn't matter really that process, but I'm going to turn the negative 3 into a 1 by multiplying by a constant. So row 1 stays, and row 3 stays. And then row 2 will change. So 0, 1, negative 1/3, and negative 4/3. So row 1 and row 2 are done. Now I have to turn row 3 into 0, 0, 1. So I'm going to use that row 1. I'm going to say negative row 1 plus row 3. So we're going to write down 1 and 2. Third, negative 4/3. And then we're going to change row 3. So 0. Negative 1 plus 2 is 1. Negative 1 plus negative 1 is negative 2. And 0 plus 2. Got to turn this into a 0. So I'm going to use row 2. You don't want to use row 1 because that's going to change this first 0. So we're going to use row 2. We're going to say negative row 2 plus row 3. 1, 1, 1, 0. So row 2 will also stay the same. Negative 4/3. Then we get 0, 0. That's going to be 1/3 minus 6/3. So negative 5/3. And then I'm going to have 4/3 plus 6/3. So that's going to be 10/3. So that's just my little scratch work. I'm going to erase that. I've got one more step, and that's to turn row 3, this guy, into a 1. So I'm going to do that by multiplying by negative 3/5 of row 3 by that constant. So 1, 1, 1, 0, 0, 1, negative 1/3, negative 4/3. And then multiplying 0, 0, 1. Let's put this here. Let's see, what's that going to give me? Negative, what am I multiplying? 10/3 times 3/5. Did I do that right? Let's see here. That becomes a 2. Those are gone. So negative 2. So then if I'm solving this, I look to this matrix that I've created. We have my x column, my y column, my z's, and my constants, or my numbers. Always start at the bottom row. This tells me 0x plus 0y plus 1z equals negative 2. Oh, I just solved it for z. Now I'm going to go what's called back substitution. I'm going to move up a row. I have 0x plus 1y minus 1/3 z equals negative 4/3. But I know z is negative 2. I just found that. So I'm going to plug that in. So I have y plus 2/3, which is equal to negative 4/3. If I solve that, subtract 2/3, that tells me y is equal to negative 2. And then I can go back up here. I have x plus y plus z equals 0. X minus 2 equals 0. So x has to equal 4. And we've got my system.